Okay, I just made a 20-minute video and listened to the audio, and it was awful. Not really sure what happened. So I'm hoping that this audio is better. I'm just going to kind of go through what I talked about. You can look at the other video on mute if you want to see it from scratch, but I'll probably just, kind of go over this and hopefully this will help out as well. So this was the first homework in 7.1, area between two curves. All of these, for the most part, are going to be with respect to X. Again, reviewing today, when we're dealing with the area between two curves, with respect to X, it's going to be your top function minus your bottom function, and your boundaries are going to be the leftmost on the bottom and the rightmost on the top. So leftmost X value, rightmost X value. Remember, all of this needs to be in terms of X, okay? Again, you should not ever then, when we're dealing with area between two curves, you should never have a net area that's negative. So if you get a negative net area or a negative area, more than likely these two are flipped or these two are flipped. Now you obviously could have these two flipped and these two flipped, and you'll end up with the right answer, but your boundaries and your integrand will be off. So for the first three examples, it literally just says set up the integral that gives the area of the region. So what I said was on the other video that you couldn't comprehend, if they go ahead and label your functions as, y subscript 1, y subscript 2, if this were the AP free response, you can go ahead and write them here since they've already been notated as such. So this is where we get just our top minus our bottom. So the y2 function is the top, the y1, the parabola, is the bottom, and then our boundaries are going from 0 to 6. So that's where we get the 0 to 6 here. Here we get our boundaries from 0 to 3. So we go 0, 3, and the top function is y2 and the bottom function is y1. So top minus bottom is y2 minus y1. If you really want to write all that out, hey, by all means, that's up to you. Over here, this is where I set it up twice. Just to give you an idea, you should end up with the same area. Because we have two functions, we got our cubic here, and then we got the horizontal line of 0 here. We have a different top than we do over here. So from -1 to 0, we would have y1 minus y2, and then flip-flop from 0 to 1. However, if this were a multiple choice question and you're really just looking for the area, don't set up two integrals. Just go from -1 to 1 and do the absolute value of the difference. It really doesn't matter if it's y2 minus y1 or y1 minus y2. The absolute value takes care of that for you, the negative area. Okay, it'll automatically make it positive. So either one works in that scenario. The bottom two on this page, you're looking at just sketch the graph that represents this integral. So we have two linear equations that were graphed, and they give us the boundaries. So we're really just looking at this area that's right here, not where we're intersecting here. This is where they give us the specific boundaries. So this obviously isn't a boundary of 0 or 4. Over here, this is the scale, same pretty much setup that I have on the answer key that's already up. So really we're just looking at from -pi/3 to pi/3, top minus bottom. So it's going to be the linear equation of y equals 2. And then this is your secant. We really don't need these other pieces, but I just graphed the entire thing on the grid with the scale of pi/6 for my x's and pi/2 for my y's. All right, let's see. So then what we did was here we just graphed each one of these. And so I sketched the graph, and I think this really needs to be up a little bit, but it's not that big of a deal. We're just really getting a rough approximation of what this sketch looks like. And so this right there is part of the given information. If the x equals 0 and the x equals 1 weren't there, then we'd have to find these two intersecting points, and those would be my boundaries. But since we do have this as part of the given information, we need to go from 0 to 1, and then it's just the top function, which is the linear, minus the bottom function, which is the parabola. Plug that into your calculator, and I showed that on the other video. you're going to get 13 over 6. Make sure your mode is radians. For our second example here, they just give us the two functions. Again, if you want to, since they're labeled as f of x and g of x, you could use that notation down here and it'd be perfectly fine. I actually made a mistake when factoring. I know I called some of you guys out. Hey, we got to know how to factor. Maybe that was AB that I was talking about, but you just set them equal to each other and you get x squared. I had a minus x minus 2 there, so I had x minus 2 and x plus 1. But in actuality, subtracting the x over, you're going to have a positive x. So that would make it x plus 2 and x minus 1 here, which would flip-flop those two. So this is going to be -2 to 1 boundary, which the graph shows that. The top function is the linear, the x plus 2. So you could write g of x minus f of x if you want. If you write it like this, there's nothing wrong with that. Just make sure you substitute it into or plug it into your calculator correctly. You don't want to make a mistake by just doing minus and then without these parentheses, because you're going to get a different answer. If you want to distribute right away as you're plugging it in and make it -x squared minus 2x here, by all means, you do you. Okay. Over here, we have a cubic and a linear. They only cross once, but that's not even the boundary that they want. Since they give us the given information of x equals 0 and x equals 2, that's automatically going to be our boundaries. And then we just go top minus bottom. So top function is your cubic, bottom function is your linear with respect to x. And plugging into your calculator, you're going to get 2. This scenario is a little bit different. If we're in terms of x, we need two separate integrals. Reason being is from 0 to 1, we have a different top function than we do from 1 to 2. So since we have different top functions, we can't just do the absolute value. We would have to set up, top minus bottom from 0 to 1. This is my y equals x equation. So from 0 to 1, it's going to be x minus 0. Do you really need the minus 0? No. Formality, that's fine. And then from 1 to 2, you get the 2 minus x minus 0. So this answer, if you plug it in, you're going to get 1. Let's think about this logically, though. If this were a multiple choice question and you were given this, just find the area of a triangle here. You got a base of 2, a height of 1. So 1 times 2 is 2. Cut it in half because it's a triangle. That's 1. So that makes sense. This should be 1. Now, if we give you some insight with respect to y, reason why I would probably choose to do this in terms of y is because I just would get one integral. So our bottom boundary is 0. Our top boundary would be 1. And then we just do right minus left. So the right equation in terms of y would be 2 minus y. The left equation would be y. So we would just do down here, it's the same as from 0 to 1 of our right function minus our left function with respect to y, and you plug this into your calculator. And if you plug it into your calculator, you don't have to be in terms of y. It's just an arbitrary variable. So just use your x variable and you'll be fine. Last few here. Okay, same thing here. You got to be careful. The top function is going to be your 0. So your 0 minus the quadratic. So that's why it's going to be a negative right here. Our boundaries are 0 to 4. You really just got to figure out how to find the x-intercepts. If you factor this is going to be, x times x minus 4. So right there, you know that you're going to be dealing with 0 here and 4 there. So hopefully that's not too difficult. Plug it into your calculator. You're going to get 32 thirds. You're probably going to get 10.666666, but round to the nearest thousandth. So this is, approximately 10.667. Either one of these works, but I really prefer this because it's exact, not a rounded value. Remember in calculus, we always round to the nearest thousandth. Over here, we have our square root of x plus 3, and then we got our linear 1/2 x plus 3. So when we look at our boundaries here, we're going to go from 0, and this is actually 4. So 0 to 4, top function is going to be your square root. Bottom function is your linear. Plug it in your calculator, you get 4 thirds. Okay. This is from 0 to 2 pi, so you're really just dealing with all of this shaded area. And it's not really, you don't really have to overthink this. So we got cosine of x, which is your just traditional graph here, and then the 2 minus cosine x, which is right here. Okay, so it kind of looks like lips, but we're going from 0 to 2 pi. Top function is the 2 minus cosine x. Bottom function is the cosine x. And plugging it in, you're going to get 4 pi. Your calculator is not going to tell you 4 pi. Your calculator is going to tell you 12.566, and that's going to be rounded to the nearest thousandth. Okay. The last one here, if this were a multiple choice question, I'm probably not going to set up 2 different equations. Can you? When I look at a graph like this, you might struggle like, hey, which one's sine of x, which one's tan of x? And in the long run, if this is a problem, it doesn't matter, because you can always use the absolute value idea where it will take care of that top function and the bottom function. As long as they're the same, it won't matter which one is, first versus second. Okay. As long as you use the absolute value, you just need to go from the leftmost to the rightmost when you have more than 2 intersections. And this is what we talked about up here or earlier today when we had multiple, and that was 24. So hopefully this helps. I know this one is half of the time before. Hopefully you can hear me clearly as well.